All right, good day to you guys. I'm going to be recording the first lesson of our new unit. So we're going to call this Unit 5. It's going to be all about multiplying and factoring some polynomials. Maybe some of these things are new words to you right now. We will hopefully start going over them and understand them. So Unit 5 learning targets, multiplication and factoring monomials and binomials. So the two that we're going to be looking at in these first couple days in this first week are 5.1 and 5.2. Specifically today, we're going to be looking at 5.1. I can multiply a monomial and a binomial together. Again, some vocabulary terms here that you may not know, but hopefully we will go over them right now. So quick reminder, please remember if you have any work that's missing from Unit 4, please do it as soon as possible. So that includes any quizzes or any Delta Math assignments. At the end of this week, I will be closing the Unit 4 quizzes, okay? All right, so some materials you're going to want to have on hand: pencil and a paper, calculator. If you need a calculator, you don't have one, you can use your phone. They have calculators there. We just need them to do multiplication. You could also open up desmos.com/calculator. You can just type that in, or you can just Google search a calculator, and Google has a calculator that shows up. And all we really need it for is some quick multiplying for today. All right, so again, here is our target 5.1, the one we're going to be focusing on. I can multiply a monomial and a binomial together. So let's look at these vocabulary terms here: monomial and binomial. And these may be new to you, they may not be new to you, or maybe they just are new as words, but you're kind of familiar with what we're talking about. So here in this green box, we're going to talk about what is a monomial. These are a bunch of examples of monomials. You might recognize the word mono in there. That prefix usually means one or singular. And the rest of it kind of means a nomial means a term, so one term. And you can notice how all of these things are kind of one chunk. They're all kind of put together and connected. Regardless of sort of how many things there are, they're all put together and they're connected. That connection is always by multiplication, or in some cases, they may be involved in a fraction, but they're all really chunked together, kind of touching each other. That's the way that I like to think about a term, is it all kind of smushed together, connected. And again, all of these are examples of monomials. Mostly, we're not going to be dealing with things more complicated like this fourth one and fifth one over here. We're going to keep it a little bit simpler, more like these things earlier on, and actually the last one there. And then, so hopefully that kind of at least introduces this idea of what a monomial is. The next thing we have here in this pink box is, what is a binomial? Hopefully you recognize, again, the prefix to this bi. Usually bi means two, right? Like a bicycle has two wheels. So a binomial is going to have two terms. And those terms, which, remember, again, those are sort of the chunks, those terms are going to be separated by addition or subtraction. That's how you're going to be able to tell that we have multiple terms. There will be pluses and minuses in between them. So here's our first example of x minus 3. The x is a term, the 3 is a term. And they're separated, again, by subtraction. Now, with a term like this, when we separate it into its pieces, we often will attribute this subtraction, which also may be thought of as a negative, to that second term. It'll go with that second one. Again, here, another one, negative 2x plus 7, two terms. The plus is in between them. 9 minus x squared. Again, they're separated, two terms. And then 3/4 x plus 10y. They all have two terms. So our learning target for today is to multiply a monomial, so one of these things, times a binomial, and to get a result. To kind of introduce this idea, I want to remember the idea of the distributive property. So we're all sort of familiar with this. This is something that you've learned about in the past. The distributive property is when you have something on the outside of these parentheses. In this case, right, isn't this just a monomial? It's a singular term. This right here is a monomial. And we're multiplying it into this thing in the parentheses, which hopefully you recognize is a binomial. There are two terms separated by an addition symbol. So we have a monomial and a binomial multiplied together. So secretly, you've already been doing this learning target before in the past. Now, there are many ways that we could simplify this particular expression. If we followed order of operations, we may do this slightly different, but we're going to look at it in terms of the distributive property. So the distributive property says to take the number on the outside of the parentheses that is multiplied, so this 5 is multiplied by this, and to distribute it. Multiply it to each term on the inside of the parentheses. So we're going to be multiplying that in. So we're going to do 5 times 3, 5 times 3, plus 5 times 4. And then we can simplify that a little bit more. 5 times 3 is actually 15. 5 times 4 is actually 20. And then because these are all just plain numbers, we can't actually put this all together. We can actually add those together and get a single number. Sometimes when we do the distributive property, if there are variables involved or something, at this step right here, we may not have like terms. So, but in this case, we can go ahead and do that. Second one here is just another example of the distributive property. The only thing here is our monomial on the outside is actually a negative number. So we do need to be a little careful with that when we're distributing it in. And also, instead of a plus, there's actually a minus inside of here. So to sort of handle this, I'm going to think about this a little bit differently. So instead of minus 3, for my purposes here, I'm going to think about this 3 as a negative value. Okay. So we're doing negative 2 times 7. Again, distributing that in there, negative 2 times 7. And then negative 2 times negative 3. That's where I'm going to think about this. So that's negative 2 times 7 plus, I know there's not a plus here, but I'm going to be adding it, and I'm going to be thinking about this as negative 2, and this is negative 3. This is just one way to think about this. So negative 2 times negative 3. Negative 2 times negative 3. Okay. Negative 2 times 7, that's a negative times a positive. So we're going to end up with a negative, and that's negative 14. Plus negative 2 times negative 3, that's a negative times a negative. The result here will be positive. So 2 times 3, we end up getting actually 6. And then again, at this stage, sometimes we may have to just stop here. But in this case, since these are just kind of plain numbers that can be put together, I can actually just add these together and get a final answer of negative 8. So this was distributive property with just plain numbers, but we can obviously spice this up a little bit, and we can throw some variables in there as well, which is what we're going to look at next. If you get stuck or you're not quite understanding something, feel free to go back in the video and watch these to kind of help you understand them again. And bring your questions to class. Make sure to ask them. All right, so here we are going to have some more distributive property examples, but we're going to be looking at the distributive property where we have some variables. Okay, nothing really changes. We do the same thing. We are still multiplying a monomial times a binomial in these distributive property examples, but we have some x's. These are the variable we're going to use right now. We could use any variable. We're going to multiply that number on the outside times each term on the inside. So I'm going to multiply 4 times x, 4 times x. And I'm going to do this as plus 4 times minus 5. 4 times minus 5. We may need to reconcile our symbols of addition and negative and whatnot at the end, but I'm going to write it this way. Okay, 4 times x. Usually we just write that together, connected. 4x. This really means the same thing. It still does mean these are multiplied together. Okay, plus. And now 4 times negative 5. 4 times negative 5 is negative 20, right? 4 times 5 is 20, and since one of these is a negative, we're going to get negative 20. All right, so now at this point, first of all, these are not like terms. 4x and negative 20. These are not like terms, so I can't actually condense these together or combine these together at all, because one of them has an x and the other one doesn't. So they have to stay separate. But I can kind of reconcile these symbols. I'm adding a negative number. Usually we like to write this using just a single symbol. So instead of adding a negative, I would prefer to write this as just simply subtraction. Now, this does lead to a different way that I could have thought about this problem before. So instead of doing 4 times x plus 4 times minus 5, I could have done this as 4 times x minus 4 times 5. And then I would end up here at the same time. Both of these methods are valid. They're both kind of considering the negative that's part of my binomial. They're just kind of doing it in a different way. Doesn't matter. Both of them are valid methods. I'm just going to try to be consistent and do it the way I did it initially. All right, and then our last example here of multiplying these two binomials together. We have this monomial times this binomial using our distributive property. I have a number on the outside. Again, I'm distributing this in. I'm going to be multiplying this 3 times both of these things. This really is kind of the goal of today. We're going to be doing things like this, but we're going to talk about how we can kind of organize it a little bit different than these arrows. So let's go ahead and write this out. We're doing 3 times negative 2x. We'll think about that in a second. Plus 3 times 4. This is a positive 4. Okay. 3 times negative 2. In this case, I have to multiply the numbers together. So 3 times negative 2 is negative 6x. And then plus 3 times 4 is 12. In this case, I can't put these together any further. This would be my final reduced answer. And if you don't quite understand this process, that's fine. This is what we are actually learning today. We're going to talk about how to do it in a slightly different method. And that method is not going to be the only way you have to do it, but it's going to be recommended because it will help us kind of expand this skill to even harder problems than this. All right, let's go ahead and move forward. So what we're going to be doing is we're going to be learning a different method than this sort of arrow method. And this method is called the area model. So to understand this, I think we need to remember what it means for us to say the area of something. So the area is often written or described as the space inside. We're going to be looking at the area of rectangles. And the reason we do that is because rectangles are sort of the easiest shape to find the area of. And we can represent multiplication of two numbers. That result is the area. So let's look at this here. We have a rectangle right down here. Sorry, this rectangle right here. Kind of outlined it in green. That's a rectangle. So the area of a rectangle is always equal to the multiplication, the product of the base, so the bottom side, or the top, they're the same, times the height. So times how tall it is. So in this case, you can see the markings on our figure. The base is 6. It's 1, 2, 3, 4, 5, 6 squares across. So the base length is 6, and our height is 4. 1, 2, 3, 4. A real convenient way to show this is all of these squares, right? We drew it as 6 squares across, 4 squares up, and we can see actually how many squares make up this shape. We could count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 24. So we could count them. That's obviously pretty tedious. And once we start getting bigger and bigger numbers, that's a little impractical counting, every time we need to multiply. But it's really interesting that multiplication can be written and represented as the area of a rectangle. And that's something that we will actually make use of. So instead of maybe doing it like this, where you have to count the boxes and whatnot, we are going to show how we can multiply two things, a monomial and a binomial, and represent that using area. And again, this method that we're learning is really going to accomplish the same goal as we were doing on the previous slide of multiplying those two things together, but it's just another way to organize it, and it's something that we can take forward with us to do more complicated problems. So that's why I'm encouraging us to learn this way. All right, so here is what an area model looks like. I'm going to kind of run through the different pieces. So right up here, when we have the two things that we are actually going to multiply together, so the monomial times the binomial, I'm going to call that the product. The product is when you multiply two things together. So this is our product. We're multiplying this monomial times this binomial. And this organizational tool here with kind of the boxes and the lines here, this is called my area model. And what I'm going to be doing is I'm going to be filling out my area model to perform the same thing that we did when we were distributing. So on the short side here, this side representing, we could represent this as sort of the height of this rectangle. I'm going to write my monomial. I have a single space here, a single length, and I'm going to write my monomial here. So my monomial was -3, right? It's right here. So this is where I put my monomial. I'm going to keep using these vocabulary terms so that hopefully they stick a little better. And then along the top, which is really the same thing as the bottom or the base of our rectangle, I'm going to write my binomial. But remember, my binomial has two parts. That's why I've sort of sectioned this in two here and given us two places so that I can put each term for my binomial in there. So I'll have -4m. That's my first term. And I'll have +9. That plus, I'm going to be using it to represent +9. So that's my binomial is going up here, where I have two places to put each term. And now I need to start filling in my box. And so this is my area model. Again, I'm using this phrasing. This is the area model. It's just a way for us to organize what things are supposed to be multiplied together. So I'm going to be multiplying 3 times 4m. So in this first box, -4m. And in the second box, I'm going to be multiplying 3 times 9. It's the same thing that I did when I distributed that 3 to each term. It just organizes a little better. So here I'm doing -3 times -4m. And I want to write my result here. So negative times negative is positive. We get 12m. 3, 4 is 12m. And then -3 times +9. Right here, I'm doing -3 times +9. I get -27. So this is the result of our multiplication. I multiplied the base, the binomial was representing our base, times the height, which was our monomial. And my answer are these two things, which I put together to state as my answer, the result of my multiplication. And I'm going to call this the area. This is the area. It's kind of a weird stretch, something that maybe is hard to understand. But again, I multiplied a base times a height. So I could call that the area of this rectangle. And each of these squares or each of these smaller pieces of a rectangle could be thought of as the sort of the area of this part. So 12m is the area of this part, and -27 is the area of this part. And then we put it together, that's my total area or the total result of this multiplication. Again, this is just a tool for us to organize this distributive property in a little bit of a better way. It's something that we can expand even further, because right now we're multiplying a monomial times a binomial. But eventually we're going to try to multiply two binomials together. And that sort of gets more complicated. I'm going to have a bigger area model that helps me really organize that. There are other ways to do it. They involve arrows, kind of like we were showing before. But the area model, once we start multiplying bigger and bigger things together, that area model is going to be really helpful to keep it all organized. Yeah. So let's go ahead and try this out. Let me do one more example for you guys, and then you can move forward and try these. So here, we're going to be multiplying this using an area model. So I have 6, that's my monomial, times 8r minus 5. That's my binomial. So I'm going to organize it here on the area model. 6 goes here. That's where my monomial is. It's only one space, one high. That's the height of my rectangle. And then here, I'm going to put my binomial. So 8r and minus 5. If this is a plus, I think of this number as positive. If this is a minus, I think of this number as negative. That symbol here goes with this particular term. All right, now we multiply. Now again, we are multiplying these things together. So we're multiplying 6 times 8r here. And I'm going to write that out, 6 times 8r, just to remind myself what I am multiplying here. So 6 times 8 is 48. I'm doing these in my head, but again, if you need a calculator, remember, make sure you have one handy to do these, especially when I'm asking you to do it on your own. So I get 48r, and then I'm doing 6 times negative 5. So negative 5 is in here, so 6 times negative 5. Let's write that out. 6 times 5 is 30. Since I'm multiplying by negative, I'm going to get negative 30. All right, and so here are the two results after we sort of distributed that in there or multiplied these things together. And we want to take them down and write them out as our answer. So I have 48r, that's my first box, minus 30. I'm going to just give this as a subtraction. I could also write it as plus negative 30, but in general, when we can use less symbols, we want to go ahead and do that. So minus 30. And that is our area, or the answer for this particular problem. These things are equal to each other. 6 times this is equal to, right here, 48r minus 30. All right. Next slide, I'm going to have you guys try it. So if you're watching this video, go ahead and pause it right now and try to do these. I have them set up for you. Make sure to draw out your rectangles. I want you to really get comfortable using this area model because, again, it's going to really, really help us for the things that we do later in this unit. So starting out here where it's hopefully pretty easy will help us once this gets harder. Again, pause this and try both of these problems on your own. All right, I am going to go ahead and go through them and do the answer. I'm going to kind of go quickly here. So 4, that goes right there, my monomial. And then 2g minus 3, that's my binomial. Again, the symbol in the middle always goes with that second number. So now we start multiplying. Multiplying 4 times 2g, and then 4 times negative 3. So I'll write this all out. 4 times 2g, that's 4 times 2 is 8g. And then 4 times minus 3. That's going to be a negative. It's going to be negative 12. So our answer here, 8g minus 12. Pretty easy. Again, you probably have some comfort already looking at this and kind of doing it this way and getting the same answer. I want you to get comfortable with this area model. Okay, this area model is going to help us do some things that this distributing just can't do. All right. Next problem, second problem here. Dropping this right here, our monomial, that's going to go on the side, negative 5. And then our binomial here, this is going to go on the top. So 10v plus 2. Doesn't matter what our variable is, we treat it the same as an x, right? So here we go. We're multiplying negative 5 times 10v. You don't always have to write these out. I like to write them out, especially as we're learning this so that we make sure to know what is happening to get this number. So negative 50v, that's what we got. Negative 5 times 2, negative 5 times 2. When we multiply that out, we get negative 10. So those are going to be the two pieces for our answer, for our area. We get negative 50v minus 10. Again, we could write it as plus negative 10, but let's just use fewer symbols whenever we can. And those are our two answers. Hopefully you were able to get those. Okay, I'm going to go ahead and clear this, and we're going to look at some other ways to kind of get a little more familiar with the area model. So in this case, we're looking at an area model that's kind of partially filled out. And what we need to do is kind of use our understanding of what's going on here with the area model to kind of find the missing pieces. So first thing that I notice is we're missing this number right here. So let's think about it, right? To get 20c, what are we doing? We're doing 10 times something. That something is what the number needs to go up here. So 10 times what is going to give us 20c? Well, couple things. I need a c for sure. I need a c because otherwise I wouldn't get this c. But then how do I get 20? 10 times what is 20? I have to kind of answer that question myself. 10 times 2 is 20. So the thing we're missing up here is 2c. Awesome. So now we kind of figured that out. And now we have a little bit of an easier one. We're missing part of the inside of our area model. We know how we get this. We multiply 10 times 7, and that's how we get that number in there. So that's 70. So we're going to go ahead and write out two things about this problem. One, what were we actually multiplying together? What was the product? So in this case, we're multiplying 10, which was our monomial, times 2c plus 7. 2c plus 7. That was our binomial. And then the other thing we're going to write out is what was the area? What was the actual result of this multiplication? What did we get on the inside of our rectangles here? Well, we got 20c and positive 70, so plus 70. So that's the product. That's what we were actually multiplying in this situation, the monomial and the binomial. And then what did we actually get as a result? That's our area, what was on the inside. Okay. Here are a couple more for you guys to try. So again, pause the video here and see if you can kind of find this out. Second one's actually a little easier, so if you want to do that one first, go for it. Again, pause the video. I'm going to start doing the answers here in 3 seconds. Okay, so let's notice the things that we are missing here. So in this case, we're missing one of the parts of our binomial, one of the terms of our binomial. But we do know when we multiply 6 times whatever that number is, we got 18q. So kind of the easy part here is, well, this doesn't have a q, so this certainly needs to have a q in order for me to get a q here. Otherwise, I wouldn't have my variable at all. So now the next question is a little trickier sometimes, but 6 times what is going to give me 18? 6 times 1, 6 times 2, 6 times 3. The thing that we're missing is a 3. 6 times 3 is 18. So our total term for this binomial here will be 3q. That way we get that. You can always test it back out, make sure it works. 6 times 3q, yep, that's what we get. And then our last part here, this one's a little bit easier, but we're multiplying 6 times negative 6 to get this box right here. And then what is our area? What did we get as a result of this multiplication? Well, we got 18q, and then we got minus 36. So that was the result of our multiplication, the area. Second one, again, a little bit easier. This one's actually more like just multiply this out. We're missing the inside, so 6 times 3x is 18x. 6 times 3 is 18x. And then 6 times 9, 54. There we go. Okay, we again want to write out our area. What was the answer for this? So 18x plus 54. Hopefully, we're kind of becoming more familiar with this area model and how it achieves this distributive thing. So let me go ahead and clear this and go to the homework. So for your homework, I want to make sure you do the first 2 Delta Math topics for week 9. These cover the area model. So these are both using the area models pretty extensively. You have to understand it to be able to do it. This is the homework assignment for our first day here. All right, guys, you guys have a wonderful rest of your day, and see you guys in class. Bye.